This video covers section H of the annuities module. In this video we're going to look at the future value of an annuity due. So we just looked at the present value where we want to know how much to pay now for later. Now we're going to look at how much do I keep wanting to pay so I have a big lump sum at the end. Okay, so what do I need to keep paying so I get a big lump sum at the end? So our formula, again, it's exactly the same as our ordinary annuity formula for our future value, but we have the extra interest payment because we're paying at the beginning. Okay. So let's look at an example. A company wishes to deposit an amount of money into an account at the beginning of each year for the next 5 years. And it's beginning of each year. So that beginning of each year is telling you it's an annuity due. Now, if you're not told that specifically, you can make an assumption of which way you're going to go, ordinary annuity due, but it should be given to you. Now, the new machine is going to cost $50,000. How much will each yearly payment be if the current interest rate is 7.2% per annum? So our amount is $50,000. Our N is going to be, it's yearly for 5 years, so our N is just 5, and our interest rate is just 7.2% per annum. We don't need to change it, so that's 0.072 because we are making the payments per year. And you can see from my timeline, I'm representing we want this $50,000 at the end of the 5 years, and we're going to be paying per year. Okay? So our formula is SD equals R1 plus I bracket 1 plus I to the positive N minus 1 because it's a annuity due all over I. Okay, now the reason why it's a positive N, is because it's future value rather than present value. So from there I need to get the R on its own. So I'm going to divide the SD by all of this. The easiest way to do that is just realizing that I is going to come to the top. So the R is going to be SD I all over 1 plus I bracket 1 plus I to the N minus 1, where we have our brackets around here because we want to multiply by all of that. So now we've got 50,000 times by 0.072 all over 1 plus 0.072 bracket 1 plus 0.072 bracket to the power of N, which is 5, minus 1 bracket. You'll see the brackets are really important, and I think the key is in the first formula realizing that there's brackets around this here because you want all of that divided by the I. So, you know, those brackets are really important. So when you go to your calculator to plug that in, you can do it all in one go. So I'm going to go through the calculator steps with you. So it's 50,000 times 0.072. I would press enter at the end. So you've got that top, which would be 3,600. Then just go straight away, divide in your calculator. Now I want to divide by everything on the bottom. So I'm going to put in an extra set of brackets. Okay, the more brackets you have, doesn't matter. You can't have too many as long as you keep closing them. So we've got bracket and then bracket again. Crap. Now when you go to your calculator, remember you can't have too many brackets. So you essentially want brackets around all of this because you want to divide the top by everything on the bottom. Okay, so when you go to your calculator, you've got 50,000 times by 0.072, press the equals, because that works out your top, which is 3,600. Now divide by, put in a bracket, then another bracket, 1 plus 0.072, bracket, another bracket, 1 plus, actually there should have been 2 brackets there, isn't there? So I go 1 plus 0.072 bracket, open bracket, and then I want another open bracket. Okay, 1 plus 0.072 bracket to the power of 5 minus 1, and then I want 2 brackets at the end. Press enter and it will spit out, oops, still in red pen, $8,078.27. Now if you're having trouble with the whole brackets, you'll see in the textbook it works out the top and then it works out the bottom and then it divides. The only problem with that is you could be approximating more than you need to, but again, don't stress too much. If that works for you, do it that way. Okay, I'm just trying to get you used to using brackets on your calculator. You'd need to finish with the therefore statement. I've run out of room. You can see the therefore statement in the textbook, but it's just $8,078.27 is required at the beginning of the year for 5 years at 7.2% to have $50,000 in the sinking fund at the end of 5 years. So you're putting in over $8,000 at the beginning of every year. Okay? What now? Practice time. The annuities section H1 has a couple of questions there for you to try.